Hi, Frank Burke from Dynasoar Rocketry here, and this video is primarily about how to swap between a pusher electric motor and setting up your model as a pure rocket glider. And I'm here in the bat cave, and I wanted to mention just a couple of things before I get into the electronic components. So a couple of things you want to think about when deciding, do I want to put a pusher electric motor in my rocket glider is, how much am I going to fly this thing as a rocket glider versus a pusher motor. If you only fly as a rocket glider every once in a while, then maybe it makes sense to put an electric motor in it and fly with an electric motor most of the time, and you'll get more use out of your airplane. But the settings and the learning curve are different for running a pusher electric motor versus a rocket glider. So it's not something where you're going to hook up an electric motor and put a battery in the nose and fly it around and learn how to fly RC and then fly it as a rocket glider. You need to be a competent RC pilot before you fly any of these at all. This is not for beginners. So a couple of things to think about are, where am I going to hang onto the model when I launch it? So a model like this one that has the wing on the top, it's very easy to grab onto the model in the middle when I hand launch it. In addition, the tail doesn't stick out very far in the back, so the propeller's not going to hit it. If I had something, here's one where the tail doesn't stick back very far, but the wing's on the bottom. So now you have to launch underhand, and you've got a very tall tail that would get in your way, and so that may be kind of hard to do that. This one here, the X15-3 Delta, is a mid-wing. So that means when I'm grabbing it to launch it, I'm having to grab here, which is only half the tube, and it may not give me a good enough purchase on the model. Some models that have a tail like this one, the Iron Cross, the tail sticks back quite a bit and the propeller would hit it. So you're going to have to make your little extender tube quite a bit longer so that the electric motor and the propeller is further back on the model, which means you may need a little bit more nose weight, or you may need to use a little bit bigger flight battery in the nose. Now consider, when you run with the electric motor and the larger flight battery, the 800 milliamp hour 3-cell pack, the entire model, instead of weighing 10.5 to 11.5 ounces, is now going to be closer to 14 to 14.5. Now these models will handle that weight just fine, and the recommended motor that I like, which is the Grayson Microjet V3 motor, will handle that weight just fine. It just means, though, that your model is, heavier. It's not quite as light and floaty as it is set up as a rocket glider. Okay, so we'll get into actually the components. Hi there, so this is a short video. This is Frank Burke from Dynasoar Rocketry, and I was asked to show how I convert or set up one of my rocket gliders to also fly with an electric motor for flying with a battery and electric motor. So I don't know if you can see this very well, but on the back of the model where the motor mount is, I have a little pod here that has a little electric motor. Now this electric motor is from Grayson Hobbies. It's called a Microjet V3, and I have an APC 6x4 propeller on it, and I've got a speed control hooked up to it, and this just slides into where the rocket motor mount would normally go. I'd use a little piece of tape to friction fit. Now this motor, when it's pushing on the airplane, it's pushing forward, so I don't need anything to keep it from falling out. I just need something to keep it from twisting a little bit as the motor runs. And You can use a little piece of tape to friction fit it. In this case, I've got a little motor hook, and so when I slide it in, the motor hook actually latches into the tube and locks it in place. So I'm going to hook up the flight battery. This particular model is set up with lights. So when I plug it in, it'll light up. Now if you can see this, Sophie, in the nose, these little strip lights, I have a little piece of Velcro on them. And I've doubled the lights over, and I just put this Velcro in the nose. Now because I didn't want to run a wire all the way back to where the rest of the lights plug in, I just leave two plugs. This is a piece of servo wire that I had left over with two of the prongs that are inside. And because these strips run off of 12 volts, I know that this little balance plug, this plug is called the balance plug. This is on a battery that has more than one cell. This balance plug is used for charging each of the cells in parallel at the same time to get a better charge. So there's a black wire and there's a red wire. So I'm going to take the black, which is the negative wire, plug that into that charge plug. And most these 3S batteries would have this charge plug for free. So I can just plug that in and you can see that lights right up. So that plug's already there. I don't need to run a separate wire. So when I'm ready to fly, I just plug that in there, and the wire goes back to the receiver. And you can see the bottom of the model. These lights are quite bright. Now I'm going to go ahead, and this is powered up, so I'm going to turn my transmitter on. So that's telling me that my transmitter is now armed the speed control. So here's my throws for roll, right, left, up and down, and the throttle. So you can see that's hooked up, normally go. Now you can see this elevon is up a little bit, so when you run with an electric motor, you're going to run the balance point about 1/4 to 3/8 of an inch further forward than you do for rocket boost, with the idea that rocket boost, you start a little bit tail heavy, and by the time it's off the rail, as the motor burns out, the propellant goes away, the model gets nose heavy, and then you have to add up trim to get it to balance. Now when you fly this with a propeller, you don't want to fly tail heavy because it's very twitchy, so you want to balance it a little bit further forward, and that's going to require then, for normal flying, a little bit of up trim to keep the nose slightly up. And because of the torque of the motor wants to make the model roll to the left, you need to give some right trim. So I have the right elevon is up a little bit, and I've figured out how much I need, so I know that that's going to be there. So as I pull this out and convert back to rocket, I'm going to have to take out those trims, because for rocket flight there's no torque and you don't want any offset on the ailerons or the elevator. So I'm going to go ahead and unplug this now. Turn my radio off. And this is the battery I use, which is a 3-cell Venom 800 milliamp hour pack. It's got the same little red JST connector that I use for the single 1S battery from E-flite that I use when I'm flying under rocket power. I've got another battery which is also a 3-cell battery with that same little charge port, so I can hook it up to these little wires in here, and the same connector. And what I use this for is if I'm going to fly it under rocket power but with the lights on, because the lights require 12 volts. So I could fly this with the pusher motor with the lights turned on or off, or I can fly it under rocket power with the little battery and no lights, or I can fly it under rocket power with the lights on. So with the lights on, I need this battery because it needs 12 volts to run the lights, and I've got this little converter, which is an old speed control, which has what they call a BEC, or battery eliminator, which takes the 12 volts from the battery. So I plug this into here. That takes 12 volts into the battery. This plug goes into where the lights are, because the lights need 12 volts. And it also goes into the little speed control, which converts 12 volts down to 5, which then plugs into the receiver, and that's what powers the receiver with 5 volts. When I run it just on the single battery, all I need is a single wire to plug the single 1S battery into, and this goes directly into the receiver, which is 4 volts, but in this case this receiver will run down to 3.5, so that's plenty of voltage to run 2 servos. So I'm going to take the motor and speed control out so you can see what that looks like. So in this particular case, normally in my kits, they're designed to balance with the receiver up here in the end and this one battery in there and maybe a little bit of nose weight. But because when you put the pusher motor in there and you have a really heavy battery in the front, it's in the front because the nose cone comes off, and that makes it easy to get at, so you don't have to have a hatch or something that you have to open and put this heavy battery in. Because that was too heavy, I had to move my receiver and the speed control down into the back end of the model. So I put a little hatch here. And I'm going to unscrew this. So I just cut a hatch, and I just made a hinge out of the decorative vinyl tape that I had. Little hatch here, and then I put a little piece of body tube in here that I put the hole in. So the first thing I'm going to do is I'm going to pull the receiver out. And I'm going to pull the one connection that the speed control plugs into in the throttle channel. So that goes to the speed control, which you'll see in a minute. And pull this wire out. This is what actually plugs into the lights, so we're not going to need that for right now. I'm going to go back here, use a little screwdriver, and pop the motor hook up so I can pull the motor out. Okay. Now this just slides right out. So this is just a motor. It's just got a plywood plate that's glued to a piece of coupler tube that fits in the motor mount, 24mm coupler tube. Now I'm going to keep pulling. So this is the speed control. This is a Thunderbird 18 speed control. You could use a Talon 25, any good quality speed control. And again, this wire goes to the receiver, which controls your throttle and also gives power to the receiver and the servos. This little wire goes to the lights, which you don't have to have if you don't have lights. And this wire goes all the way up to the front, which is where the battery's mounted. So you can see it's a very tiny little motor. Now this motor weighs about 2.25 ounces plus about half to 3/4 of an ounce for the speed control, compared to the motor, which weighs about 1.9 ounces. So you've got a little more weight. I had to mount it out a little bit so that the propeller wouldn't hit the tail, so it had to stick out a little bit further. So that's why this piece is so long. That's the normal length of a motor. So it sticks back another inch or so that the propeller doesn't hit that. Okay, so that's that. So if I want to run just as a rocket, then all I would do is take my wire with, this is just a servo extension, it's a 24-inch servo extension with the little battery lead that comes in the kit. And I can plug this into any one of the slots in the receiver because it'll power no matter where you plug it in. So I just plug that in right there, and then I'd run this battery down into the body tube, out into where the nose is. And then I'd use my regular battery like normal that would go right there in the nose. Now, the thing you have to consider is you have to balance it in each of the configurations. So right now it was balanced for this heavy motor and the battery in the nose cone. Now I've already checked, and I know that when I run with a single motor for rocket power in the back and this little battery up front, I need these little extra weights here. So this is about 10 grams or a little less than half an ounce. So I've got Velcro up in there, and I'm going to put that. So I've got some little forceps here, so I'm just going to grab this and stick it up there in the nose so that the model is balanced. And then that's going to go into the model. The other thing I need to remember is that I had trim on here. Because of the electric motor, I had up trim. So I can see on my radio I've got -22, that's up trim. So I'm going to take that off. Now it says 0. And I'm going to get rid of the right trim. It says +16. Now it says 0. So I've gotten rid of the trim. And then I'm going to have to go, can you see the menu in there? Can you see the words?
No, yeah, I can now.
Okay.
Yeah.
So I'm going to go in here into flap system, where it says inhibit, and I'm going to select switch D, which I've already got my launch setting, which is 0 trim for boost and up 33% for glide. So I need to turn that on. So I've gotten rid of the trims. I need to turn on my flap so that when I fly, I can hit the little switch and I have my glide trim. So now that would be ready to go. All I need to do then is put the receiver back in here with Velcro, close up my hatch, and I'm ready to go. So the third way that I can fly this then, this is a rocket glider with lights. So again, I've talked about you need a 3-cell battery to power the lights. So I made this little harness, which again, this goes to the receiver to power the receiver with 5 volts. This goes up to the nose to this little battery now, which is a 3-cell battery. That goes up into the nose, and I can hook that up to the nose light. Now I've also made a note that when I fly with this battery, because this battery is a little bigger, I need to take out that little piece of weight because I don't need that, because this battery weighs a little bit more. So I put that battery up in here. I'd hook that up to the wire going back to the receiver, and then in the same way, if I wanted, I could plug into the black and the furthest away red connector, and I've got my nose lights if I want those. And then again, I just run that wire down in here with this little converter or speed control, and I'd hook that into any one of the connectors in here, stick everything back, and wire it back up. So, hope you found that interesting. Thanks.